Now it's time to return to the question of arguments, maybe the central theme of our class. And any argument that can be modeled or symbolized in our system, we can determine to be valid or invalid in a systematic, just formulaic kind of a way. Let's look at an example. So suppose we have the following argument. Spock laughs only if he's stoned. We all know that the only time Spock ever laughs is that episode where they go down to the planet and the flower sprays him and he gets stoned.
You're out of your mind. You were told to report to me at once.
I didn't want to, Jim.
Okay, second premise. Spock is stoned right now. And suppose maybe we know this because we spiked his drink, his Romulan ale. So Spock laughs only if he's stoned, and Spock is stoned right now. Conclusion. Spock is laughing right now. And you can imagine giving this argument because you spiked Spock's drink and he's in the other room and you're betting that he must be laughing right now. Okay, let's symbolize this argument within our system. The first premise, Spock laughs only if he's stoned. We could call that L arrow S. Okay, the L is for Spock laughs, and then the S is for Spock is stoned. Remember, only if signifies the consequent. So the S is the right side. And the second premise is easy. Spock's stoned right now. That's S again. And meanwhile, the conclusion is L. So now we have symbolized that argument, and we can use our system to determine if it's a valid argument in a formulaic way. And the first thing we're going to do is set up a truth table with the premises of our argument and the conclusion listed. Premises on the left, and the conclusion will be on the far right. There we go. And I've put a line to separate each premise. There's only two. And then two lines to indicate which one is the conclusion. It's helpful to have something different to separate the conclusion from the other things, because that's going to be important. So now we set up our truth table, and I'm going to start on the right with L and do true, false, true, false. Then when I come to S, it's going to be 2 trues, 2 falses. And I just repeat those values across the table. Then I complete the truth table. Now, in this case, it's really easy because there's only one operator, right? So it's the arrow. The only time it's false is when it's true on the left and false on the right. That happens only here on the third assignment. And on the rest of the assignments, it's true. So now that was step 1 of the process of determining if the argument is valid or not. And now the next step of my process just involves reading off my results off the truth table. And I'm going to be looking for a certain outcome. And before I do that, let me make sure I cross off the values for the L and the S here. I only want to be looking at the main operator of my premise, which is under the arrow. And to understand the next step of the test here, think about how we defined a valid argument in the beginning portion of the class. It's an argument in which the truth of the premises guarantees that the conclusion would have to be true. Or another way of putting that was, it would be impossible for the premises to be true and for the conclusion to be false at the same time. Now, what we have before us in a truth table is a way of verifying whether that's the case or not. Because remember, when we were just thinking about arguments intuitively, we had to just imagine a case where the premises were true and try to imagine the conclusion being false. What we've got in the truth table is we've covered every possible case. That is to say, each simple sentence is either true or false, and then we know what the value of the entire premise is for each case, and we know what the value of the conclusion is for each case. They're these. So now all I got to do to see if the argument is valid is ask the following question. Is there an assignment, that is there just at least one assignment, on which the following two things happen? On which all the premises are true, and at the same time, the conclusion is false. And what this corresponds to, if we do find it, is that case where we try to imagine the premises being true and the conclusion being false. And when we can do that, that means that the argument is not valid. So this is a test that tells us if the answer is yes to our test, we know the argument is not valid. It's an invalid argument. And meanwhile, if the answer is no, if there is no such assignment, then that corresponds to there being no possibility, it being impossible for the premises to be true without the conclusion being true. So that means it's valid. So now let's see whether that's the case with the argument we have above. Let's check the first assignment, and we see both premises are true, but the conclusion is true on that assignment. We're looking for an assignment where the conclusion is false. So what does that mean? If you said that means it's valid, then you have jumped the gun. Remember, we're just looking for at least one assignment where this happens. We've only checked the first assignment so far. So that was a trick question. The answer is, that means absolutely nothing. It just means that we have to keep looking. We haven't found the assignment that we're looking for, where the premises are true and the conclusion is false. So we continue looking, and on the second assignment, we find that both premises are true, and at the same time, on that assignment, the conclusion is false. Now, that was what I'm looking for, an assignment where all the premises, in this case 2, are true, and the conclusion is false. So that means that the argument is invalid. Now, maybe you find that result surprising. Let's go back and look at the argument we were talking about. Spock laughs only if he's stoned, and he's stoned right now. Doesn't that mean that he must be laughing right now? It doesn't, and this is one of the tricky things about conditionals that we talked about. Only if specifies a necessary condition. It's a necessary condition for Spock to laugh, that he be stoned. That doesn't mean that he laughs if he's stoned. Maybe sometimes, even when he's stoned, he doesn't laugh, because, that's how serious a guy Spock is. So this is an invalid argument, and it's an example of a type of argument that's commonly mistaken for a valid argument. And so we have a name for this type of argument. We call it affirming the consequent. And it's what we call a formal fallacy. And maybe we'll talk later about what exactly we mean by formal fallacy here. Now let's look at another argument. And let's say our argument starts with the same premise, that Spock laughs only if he's stoned. But this time, suppose the second premise is that Spock is laughing right now. And the conclusion is that Spock is stoned right now. So this argument is very much like the last one, except that the second premise and the conclusion have been reversed. So when we go to symbolize the argument, the first premise is going to be the same thing, L arrow S. And meanwhile, the second premise is, this time it's L, and a conclusion is S. So once again, we lay out our truth table for the premises on the left and the conclusion on the right, and we set up the values for S as alternating, the values for L as alternating by 2's, and repeat those throughout the table. The values for the first premise are determined by the arrow rule, which dictates that this will only be false in the second assignment, where remember the left side true, right side false makes it false, and in the rest of these cases it's true. And let's cross off the values under L and S because our main operator is all we care about. And that completes step one for this truth table. The next step is to ask the question, is there an assignment, at least one assignment, where all the premises come up true and at the same time the conclusion comes up false? So let's go down the line and see what we got. On the first assignment, both premises are true, but the conclusion is true on that assignment, so that is not what I'm looking for. And once again, that means that I keep looking. On the second assignment, the first premise is false. Well, I'm looking for an assignment where all the premises are true, so that's also not what I'm looking for. So I still haven't found what I'm looking for. On the third assignment, the second premise is false, and so once again, that's not what I'm looking for. And on the last assignment, the second premise is false again, and so that also is not what I'm looking for. And this time, that's the last assignment. So what I'm looking for just isn't there. So the answer to my question is no, there is no assignment where those premises are true and the conclusion is false. That means my argument is valid. Remember, the concept of a valid argument is that the premises being true is incompatible with the conclusion being false. And that's what we have right here. And this is a type of argument that's also something we're going to want to be able to refer to by name. This is a type of argument that is always valid because I'm affirming the antecedent. Notice how the second premise of the argument is the antecedent of a conditional. So if that conditional is true, and then the antecedent of that conditional is true, that guarantees that the consequent of the conditional has to be true. This is referred to as modus ponens. And modus ponens is a valid argument form. I hope you're not too put off by this crazy Latin name. Some of these argument forms have these crazy Latin names because people wrote in Latin when they were first exploring these ideas, and the name stuck. Modus ponens basically just means affirming the antecedent. Not to be confused, unfortunately, with affirming the consequent, which, recall, is not a valid form. Now, the main point here was not to memorize a valid form and an invalid form. The main point here was to understand the test of whether an argument is valid or not within our system on a truth table. And that's a test that will give you an answer every single time. It will give you the correct answer if you apply it correctly. Is the argument valid or invalid? So that's kind of a nifty thing to have.